Hi, the section we're talking about today is 10.7, the law of sines. Yesterday we went over 10.6, which is law of cosines. Law of sines, law of cosines are the two ways to find angles and sides on triangles that are not right triangles. If you have a right triangle, a whole lot easier to do one of the things from sections 1 or 2 where you're doing SOHCAHTOA. Just a lot less work. But first thing is labeling triangles. I did a much better job in yesterday's notes. I'm going to assume that you watched those already. And just quick say, well, our angles are always going to be capitals, A, B, and C. And in order to get the equations to work out right, the sides are going to be lowercase, but the letter that they are is always going to be the same as the angle that's opposite it. So this has to be side B because it's across from angle B, lowercase c for this side because it's across from angle C, and so on with the A's. Alright, law of sines. Law of sines, there's three fractions. You're going to use two of the fractions at a time, but which two you use depends on what letters you know between A, B, and C. So law of sines then is going to be sine of capital A divided by lowercase a, so the sine of an angle divided by the side that's across from it, equals sine of capital B over, you probably would guess then, that'd be a lowercase b, and you'd be right, equals sine of capital C, sine of angle C, divided by side C. Like I said, you'll just use two of these fractions, perhaps the left two, perhaps the right two, or the first and the last, just depending on which sides and angles you know or are looking for. Works when? If you think back to geometry and your triangle congruence theorems, we said that law of cosines yesterday were the ones that you knew more sides than angles. So side, angle, side, 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 side. Here you have an even number. If you're using the first two fractions, you have two angles, angle A and B, and two sides, sides A and B. So for these, it's not going to be the side-heavy law of cosines. Instead, it's going to work when you have an angle, side, angle. In case I'm totally losing you on this triangle congruence theorems thing, quick try to draw a triangle. If I have a triangle, then this angle side angle would be, if you know this angle here is maybe, we'll say 60 degrees, this angle here is 80 degrees, and you know the side between them is 3. Then you could use law of sines to find, you know, some missing things in your triangle. Really, you could find any of the sides knowing that. This will be like our third example. Another one that we had was angle, angle, side. So instead, if we had this triangle, if you knew the angle for the 60 and the 80, now if you knew that this side here was maybe 7, then you'd have an angle, angle, side. You have two angles, and you have the side that's not between them, an angle, angle, side. Now one that's not a triangle congruence theorem, we actually visit this more later on in the chapter, would be the side-side angle. Or as many high school students remembered, if you flip it around the opposite order, spells a naughty word. But this isn't a triangle congruence theorem. It's actually kind of cool. We're going to look at it in this chapter. The reason it's not is there's more than one possible triangle with that. If we had, say, side-side angle, so side, side, maybe I'll say this one here is 9, and an angle of 60. There's two possible triangles you could get that would both have sides of 7 and 9, and the angle here being 60. And we look at that and be able to figure out, well, what would both of them be using this law of sines. It's really pretty sweet, that unit circle. But okay, anyway, so we can use law of sines for any one of these three. Technically, just those two, because you have two options for answers there. But let's go through and do it. I have three examples today. First two are pretty straightforward, and the last one's kind of a trick that you'll see shows up sometimes. Actually, I'm going to back up and maybe make one other comment. If you're not into the triangle congruence theorems, law of sines I find easier to use than law of cosines. So I always look for this. If you know an angle, I'm going to call it an angle side pair. Plus one thing. If you know an angle and the side that's across from it, so if you know angle A and side A, so this angle, this side, you have a pair, you have a complete fraction. Then if you know any one other thing, law of sines will work. Maybe not to give you what you're looking for, but you could at least find out more about your triangle law of sines. Or if you know this angle and this side, and one other side or one other angle. law of sines would work. So that's kind of my default because I like law of sines more. It's typically easier. So I'll look at this triangle and say, okay, I know an angle, I know the side across from it, I have a pair, and then sure enough, I have this angle, I'm looking for the side across from it. If I lost you, let's go through and label the triangle. That'll help. So if I label the triangle ABC this way, 4 then has to be lowercase letter c. X then is going to be lowercase letter b. And if we go through and look at those three fractions that we had, so we had sine of a over a equals sine of b over b equals sine of c over c. If nothing else, I maybe gave you a chance to catch up drawing your triangle. But now, one of the fractions we use has to be the fraction that we know. So we're going to have to use this sine of c over c because we know angle c and we know side c. And then we're looking for lowercase letter b, so this has to be the other fraction that we know because it has our unknown in it. And sure enough, we know angle b. So now we know capital C, lowercase c, capital B, and we don't know b. So the two fractions that we're going to use then would be these two. Let's see if I can just snag them. Good enough. I'll take and pop those down here. And I'm going to get rid of that first fraction, just get it out of the way. So if you write out your equation, you're a lot more likely to get the problem right. And when I ask you to know it from memory on the test, you'll have it in your brain. So please do that. Please show your work. So sine of capital B, so that's sine of 65 degrees, over side B, so that's going to be my unknown, that's x. And now that equals sine of C, so capital C is 46, so sine of 46 degrees, divided by lowercase c, that's my 4. And once you label your triangle and write out your general equation, it just makes the problem a lot easier to fill things in. So now we're here. For this are variables in the denominator, and that messes people up. The most common mistake is people divide by sine of 65, but then you still are left with 1 over x. So I'd encourage you to do the old cross multiplying. So you cross multiply and divide. So it's going to be x times sine of 46 equals 4 times sine of 65. If you forget that, it's kind of like the whole ichthus, like the fish thing. So I'm going to say x times sine of 46 equals 4 times sine of 65. And now once we're up to there, our variable's out of the denominator. So that's good for us. And now we just want to get x by itself, so we divide by sine of 46 degrees. Divide by sine of 46 degrees. We should be able to take, since we know everything on this right side, we can punch it all in at one time. One word of caution, most calculators are going to take, and after you hit the sign button, they're going to put a parenthesis there. You need to end the parenthesis before you do division. Otherwise it takes this sine of 46 and crams it all up in there. So essentially you're doing sine of, the denominator as well. So if I flip over to my graphing calculator, and I can say I have 4 times, and you could do the multiplication if you want to, or just skip it, 4 sine of 65. I end my parentheses, divided by sine of 46. And if I punch all that in, I come up with 5.04. And if I would go back up and look at my triangle, 5.04 seems really believable. So x equals 5.04. And sure enough, if that's 4, it could be 5. 4 is about that much, so chances are we're right. Then, jump over to the second example. Second example, we're going to be finding an angle. So maybe pause it a sec if you want, and quick draw this triangle out. And once you get that drawn in, then your next step is to go through and label it. And it doesn't matter where you start or which direction you go around, you just want all your angles to be capital. Now you start needing to be a little bit more careful as you label your sides, because the sides are lowercase and they're the same as the angle that's opposite it. So 4 then has to be side B because it's across from angle B. 11 is side C, it's across from angle C, and so on. Now let's see. We're looking for an angle. I didn't really write in which angle we're trying to find, so maybe let's go for this angle over here. So we're going to say we're finding angle A. So when we're looking at our law of sines, I'll maybe quick write out all three fractions. So we had sine of A over A equals sine of B over B equals sine of C over C. So which two fractions do we use? We have to use the first fraction because we're looking for angle A, and that has our unknown in it. Whichever other one we use then, since our unknown is right here, we need to know side A, which we do. The other fraction we have to know those two, so we can't have more than one unknown and then still be able to solve for it. So this fraction isn't going to work because we know side B, we don't know angle B though. So this fraction has to be our second one, the sine of C over C, because we know angle C and we know side C. Let's see if I can maybe move those a little closer together. Not easily. Alright, so now if we take and just fill these in, so sine of A, some people leave it capital A, I like seeing a theta there, so sine of theta, divided by side A, so that's going to be 10, equals sine of capital C, so sine of 82 degrees, divided by a lowercase c, so that's going to be 11. Now just like the last example, we could cross multiply and then divide. That's no problem. It's one extra step though. If you have one like this, sine of theta divided by 10, what would save you one step is to just multiply by 10. So if you're a big fan of cross multiplying, go for it, it's going to work. But I'm going to instead just say, I could cancel out my 10 that way. And I'm left with sine of theta equals, let's punch in that right side. If I do it the way it's written, I have sine of 82. Make sure you end your parentheses before you multiply by 10, because we're not multiplying the angle 82 by 10 to make it 820, we're multiplying sine of 82 by 10. And then we take and divide that by 11, and I get 0.9002. I was always told to write those out to 4 decimals, so 0.9002. In a moment we're going to use the answer button on our calculator, so it doesn't really matter. We're not really rounding here yet. My left side then is sine of theta equals that. But we're trying to get theta. So you could say, well, theta we did sine to it, got this ugly decimal. So now we undo sine by doing inverse sine. And you'll do one of those inverses every time you're looking for an angle. But inverse sine then on the left leaves us just with a theta. And now I can go back to my calculator and say inverse sine. And now I'm going to do my answer button, just to keep myself from having to type all that in. And I'm not rounding till the end, so 64.19. I'm going to round that to 64.2 degrees. So that's the second example. One more to go, and then that rounds out law of sines. So this here I referred to as the tricky one, and by that it's not really hard in doing the math, it's the seeing what the first step is. It's not uncommon when we have a quiz on law of sines, law of cosines. I get at least one person in each class that comes up and are all concerned, they just don't know where to start. And the reason is, I said earlier, you want to have an angle side pair, and this one doesn't. So I'm going to maybe go through and label my A, B's, and C's just to kind of start off. And we have side A, so then this over here would be lowercase c, this would be B. You need to pick what we're looking for, so maybe I'll say that we're looking for this over here. So my B is going to be my side X, we're trying to find this side over here on the left. Alright, so the reason it doesn't seem to work is we need to know an angle side pair. We know side A, but we don't know angle A, so we don't have a complete fraction there in law of sines. We know angle B, but we don't know side B, so we don't have a complete fraction there. We know angle C, we don't know side C, so we don't have a complete fraction there. So it seems like we're stuck. Then people will go and they'll try to do a law of cosines, they don't have nearly enough information, and then you just kind of get to panic mode. But if you think back to what we know about triangles, if you know two angles on a triangle, you totally can figure out this other one. That angle there, angle A, all the angles of a triangle add up to 180 degrees. So if we were to go and do 180 degrees minus 80 degrees minus 45 degrees, we know then that that has to equal 55 degrees. So in other words, you could say this angle A right up here is 55 degrees. And now once we know that, we're back to what we did in that first example. You just go through and solve from there. So real quickly I'll do this. If we're looking for x, that's our unknown. So we know that we need sine of b over b, because that has what we're looking for. Our other fraction has to be our angle side pair, so it's going to be sine of a over a. And then we start plugging in numbers. So sine of b, so sine of 80 degrees, all over our unknown, I'll put in an x, equals sine of capital A, so sine of 55 degrees, divided by 6. Our variables in the denominator, so you need to be careful. You don't divide by sine of 180, instead you go through and do your cross multiplying, and we'll end up dividing to get the variable by itself. But first we have 6 times sine of 80. Usually they do the number before a sine or a cosine. So 6 times sine of 80 is a little better than sine of 80 times 6. Equals x times sine of 55 degrees. And now once we're there, we're trying to get x by itself. So we divide both sides by sine of 55 degrees. And now we have x by itself, and it's just a matter of punching it all into our calculator. So if I pull up my calculator, and you could kind of estimate beforehand, if the side on there is 6, we're looking at something that's probably 7.5 or 8. So that's kind of the ballpark we want to be in. So if I do 6 times sine of 80, make sure you end your parentheses there in the numerator, that's key, divided by sine of 55. And we come up with 7.2, which is pretty reasonable for what we were kind of eyeballing it. So then final answer, x is going to be 7.2. That rounds out all the notes on law of sine.